Guys, so in the previous session we have seen what is the meaning of sequential circuits, right? And also we have seen what do we mean by a latch, what do we mean by a flip flop, right? So now we'll try to define one more latch called SR latch, right? So any kind of a latch or any kind of flip flop we can able to construct either using NOR gates or with the help of NAND gates, right? So basically if you are going to construct with the help of NOR gate, we can do like this, right? So it's a kind of synchronous SR latch. Why it is synchronous? Because everything is under the control of one point. I can call it synchronous latch. If I am saying that it is asynchronous latch, it is not in our hands. So the inputs can be anything. It can able to work accordingly, right? So I can call this as a synchronous SR latch, right? So how this circuit is going to work, right? So for example, can I assume that the previous output is 0, right? So guys, before this assumption also, is there any chance to solve this one directly? Is there any chance? For example, if I am assuming that S and R are 0, 0, 0, 1, 1, 0, 1, 1. Okay, fine. What about the remaining circuit evaluation? Is it possible to solve it directly? No, right? Because here this Q1 is input to here, but this Q1 is dependent on this circuit. If this input is dependent on this one, mean that entire completely it's a kind of a self loop, right? So you cannot able to solve it directly. So for that reason, I am assuming that Q1 is 0. If I am assuming that Q1 is 0, what should be definitely at the Q1 bar? 1. It should be definitely at the Q1 bar is 1, right? So now, if Q1 is 0, what is this input? 0. This input is 0. Assuming that SR is 0, 0. Meaning that here S is 0, R is 0. So as I am getting some kind of a clock signal, I can say that this is 1 and here also it is 1. Now, what is AND gate output? 0 and 1 is 0. That input will be coming here. What is this meaning? What is here? 0 and 1 is 0. You are getting. Now, if you know these two inputs, can you able to calculate for NOR gate? 0 R with 0. 0. For that complement is 1. Means are we going to get this one or not? Yes. We are getting. We are getting. Now, if I am going to give this input to here, this input is what? 1. Now 0 R with 1. 1. 1 complement is 0. 1 complement is 0. Means we are going to able to work here. Right? Now try to make it repeat again. 0 with 0, 0. 0 NOR with 0, 1. 1 will come here. 1 NOR with 0, 0. Meaning that it is going to be repeating the same process or not. Means if I am going to give Qn as 0, what is the next state you are going to get? 0 only. 0 only. Am I right or not? Yes. Okay. I have assumed that 0 is the input. 0 is the previous state. Now, I am trying to assume that 1. How this circuit is going to work, right? Meaning that for the same SR 0, 0, your previous output, assuming that it has a 1. What about this Q1 plus 1, right? So, Q1 will comes here. This will be 1. And this 0 and 1 is 0 as it is. When 0 and 1, 0 R with 1, what is going to happen? 1 complement is 0. Means is it getting or not? 1 complement is 0. Yes, we are getting, right? Now try to give this input to here. 0. This input you are going to get because of this 0 and 1. So you got 0 1. 0 R with 0 is 0. For that complement is 1. Means are we going to get the same input? Yes. Meaning that if I are going to pass Q1 as 1, you are going to get Q1 plus 1 also 1. What is the meaning of this one? When the inputs are 0, 0, its outputs are purely depend upon Q1. Its outputs are purely dependent on Q1. Meaning that whatever the inputs that you are going to pass, those same inputs are going to get at the output. Or if I say whatever the previous outputs I got, the same outputs I am going to get for the next location if I am going to pass 0 0 as input. 0 is input, right? If 0 is passing, 0 is getting. If 1 is passing, 1 is getting. What is the meaning of this one? Can I say that this is latch mode, or I can call it as latch state, or I can call it as the same output is going to be hold. Am I right? Yes. So meaning that when 0 0 as a input, your circuit is going to be work as latch state. Okay, fine. Now what you can do now? Try to take another variation of input. So I have taken the same image only. Right, now try to solve. What are the other inputs are possible? One is 0 1, right? 0 1, right? So S is now 0, R is 1. When S is 0, R is 1. Can I assume that Q1 as 0? I am assuming that Q1 as 0. If I am assuming that Q1 as 0, this should be 1. This should be 1, right? So now try to observe. This is 1, and here also it is 1. 1 and 1 is 1 here. 1 and 0 is 0. Now if I am assuming that this is 0, that same output will be passed to here. 0 R with 0 is 0. Complement is 1. Are we getting? Yes. Fine. Now try to pass the same input here. 1 R with 1. 1. Its complement is 0. Its complement is 0. Okay, fine. Now try to repeat the process. 0 passed to here. 0 NOR with 0. 1. 1 will be passed to here. 1 NOR with 1. 0. 0. Means if I am going to pass here 0 as input, what is the output you are getting? 0 only. Getting 0 only, right? Now try to pass another input. For example, I am thinking that it is 1. Output may be 1. If that output may be 1, here the value will be 1. If the value will be 1, what about 0 R with 1? 1 and its complement is 0. Means are you going to get it or not? 1 complement is 0. Okay, fine. Now this input, this output I am going to send it to 0 here. 0. Now 0 R with 1. 0 R with 1. 1. Right? 0 R with 1 is 1 and its complement is 0. Right? Means that we are not getting the earlier data. We are not getting the earlier data, meaning that it is generating Q1 plus 1, right? What the Q1 plus 1 is generating? 0. When 1 is the input for the combination of 0, 1, what about the Q1 plus 1 state? 0. 0. Now try to repeat it. Right? If this 0 is coming here, 0, 0, 0 is 0, NOR is 1. Is it working or not? Q1 plus 1 is 0, Q1 plus 1 var is 1. So it is working. Now this 1 will be coming here. This 1 will be coming here. 1 and 1 is 1 R with 1, 1 is 1. Its complement is 0. Mean the next state is 0. Next state is 0. That state will be coming here. 0 R with 0, 0. Its complement is 1. So now they are matching. Am I right? Yes. Means what can I write? If I am going to have 0, 1 as input, 1 as the Q1. What about Q1 plus 1? 0. Q1 plus 1 is 0. It means that I can call it as reset state. So what I did here, when you are going to have the inputs as 0, 1, 0, 1, if the previous output is 0, it is going to make your system as reset state. Or if the previous output is 1, it is going to make the system as reset state. We can simply understood that when your input is 0, 1, you can make sure that it is a resetting mode. Make sure it is a resetting mode, right? Similarly, try to do it for another one. Right? So what will happen? If I am going to give 1, 0, right? So S is 1 and R is 0. S is 1 and R is 0. R is 0. Now these are going to be 1, 1. So here you are going to get 0, here you are going to get 1, and I am assuming that Qn is 0. So here it should be having compulsory 1, right? So meaning that when Qn is 0, Qn bar should be 1, when Qn is 1, Qn bar should be 0. So that is what the condition is following by the earlier case also, right? So earlier Qn plus 1 is 0, so Qn plus 1 bar is 1, so it is working accordingly. So now try to observe, if I am assuming that Qn is 0, that same input will be coming here, 0 or with 1, 1 complement is 0, 1 complement is 0. If 1 complement is 0, so what you are getting here? 0. Am I right? So which means that is it working accordingly? No, right? So try to observe once again. If I am going to have 0 as here input 1 0, that same 0 will be getting here and 1 will be there. 1 or with 0, 1 complement is 0, but actually we should have to get 1. We have to get 1, right? So now try to pass this input to here. Try to pass this input to here. If I pass this, 0 0 is 0, its complement is 1. Its complement is 1. Now try to repeat the process. Here I am getting 1. 1 with 1 is 1. Its complement is 0. Now try to pass 0. 0 with 0. 0. Its complement is 1. 1 with 1. Its complement is 0. Means that at certain point of time, is it working as per our expectation or not? Yes. Means that as electricity is passing very fastly, signal is going to be very fast, right? So meaning that after 1 iteration or after 2 iterations, our expected output is getting. Am I right or not? So it is working according to our expectation. So meaning that if 1 0 as input and if you are going to give the input as 0, what about the Qn plus 1? 1. Right. Initially I have taken as 0. I taken as 0. After 1 iteration or after 2 iterations, it is going to always produce 1 as output. So that's why I have written like that. Right. Now take out one more possibility. 1 0 as input. What might be the assumption of Qn? 1. Now try to assume it has 1. If it has 1, it should be 1 now. It should be 1. When 1 and 1 are with 1 is 1 and its complement is 0. So it is in the first state itself, it is satisfying. 1 complement is 0. The same input you are going to get here, 0 or with 0 is 0, complement is 1. Repeat the process, it is going to be satisfied accordingly, right? Meaning that if Qn is 1, what about Qn plus 1? 1, right? Which means that I can say that this is set state. Set state, right? So meaning that when you are going to give the inputs as 1 0, irrespective of the previous output, you are always going to get the output as 1 for the next state. See, basically I can call this as a next state and this one I can call it as present state, right? So fine. What is another possibility is there? Another possibility is 1 1 1 1, right? Here also we are going to have two possibilities, one is 0, another one is 1. Now check how it is behaving. Right? Now try to observe. Here if I am going to give S as 1, R as 1, and you know these clock signals are always 1 based on like level of triggering we are using. So here you are going to get 1, here also you are going to get 1, right? So in NOR gate, 1 with any operation, what is going to happen? Always 1, sure, right? So try to evaluate, right? If I take Qn as 0, if I assume that Qn as 0, so here you are going to get 0, so actually we are expecting here as what? 1, we are expecting it as 1, 0 or with 1, and complement is 0, meaning that we are not getting this one. Okay, okay, fine. For first iteration, it is okay as signals are passing very fastly. It can get the next generation value. That is, assume that. If I got 0, this 0 will be passed here. 0 will pass here. 1 R with 0, 1, its complement is 0. Its complement is 0, right? Now observe, here you got 0, here you got 0, here you got what? 0. What does it mean? Is it satisfying? No. Earlier case what happened? If I give 0, 1 you got, so anyway 1 you were expecting, but anyway we got 0. If I process it, we got next value as 1. So it is altering the values. But whereas coming to this case, it is not altering. So if I am going to pass 0 as input now, 0 as input, 0 R with 1, 1 complement is 0. Now at this step also you can understood that even if I am going to give 0 as input, you are always going to get 0 output. 0 for the Q1 bar, but it should be 1. If you pass 0 here, 0 with 1 is again 0. Here if you do like this process continuously even n times, you are going to get always Q1 is 0, Q1 bar is 0. So is it correct one? No. Meaning that your circuit is not going to be work perfectly for the inputs 1 and 1. So I can say that these two are undefined states. These two are undefined states. Okay. So if I say this entire thing, technically call it as characteristic table. What is the meaning of characteristic table? Which is going to clearly explain how your circuit is going to be performed, right? So earlier we have seen these definitions. So we can call it as characteristic table. So once we know the characteristic table, can we able to draw its characteristic equation? From characteristic equation, can we able to draw its circuit? Yes or no?